Congratulations, you made it to the last session of the day. You deserve a drink in about 30, 40 minutes. So if you haven't been to a previous session, my name is Oded. I'm a solution engineer at VMware Tanzu. And with me, Scott.
Hi, everyone. My name is Scott Rosenberg. I'm the lead architect and the CTO of TerraSky, working a lot with all of the Tanzu portfolio, Kubernetes, and overall a big Spring aficionado, as we call it.
That's a good definition.
And today we're going to talk about Tanzu Application Platform, which is really an amazing new modular next-gen platform as a service tool that really has a lot of benefits and deep integrations with the Spring framework. When we look at, in general, the big issue today is when we're talking microservices, when we're talking about this world, one of the biggest challenges is the learning curve, the extra cognitive load that's put on you, the developers, when you start to build a platform. Instead of dealing with code, you're dealing with auto-scaling, you're dealing with networking, you're dealing with 17,000 different Kubernetes CRDs, and it's a lot of fun. No, it isn't. And basically, one of the things that came out of the whole Spring world was very common was the Cloud Foundry world. We had amazing integrations there with Spring. But as we were moving to Kubernetes, we really wanted this openness. We wanted this ability to have all of the power of Kubernetes and at the same point give us that simple CF push experience. And that's really what TAP comes to give us.
Absolutely. It's really trying to be a platform as a service for the Kubernetes world, but being customizable and modular and not being locked down and opinionated from day one.
Exactly. And if we look at this, one of the biggest issues also, forget Kubernetes. How about everything before that? How do I start building a microservice? How do I bootstrap? OK, in Spring, it's pretty easy, start.spring.io. But how do you bring in your organization's standards into that? Start.spring.io is great, but you may have your own organizational standards of how you want certain layouts to work within your code. And those are things that start.spring.io doesn't give me. And that's where TAP really comes, not to replace, but how do we add on top of that? How do we really adapt this platform to you? So if we look at really the idea in Tanzu Application Platform, number one, I think the most important, well, there are 3 bullet points here, is what we see just on the bottom. All of the different Kubernetes distributions, this is just a few. But whether we're running on Tanzu, hopefully, or OpenShift, or AKS, or EKS, or GKE, or Rancher, it doesn't matter which Kubernetes this platform will run. That means it runs any cloud, anywhere.
Exactly.
Beyond that, we can really unlock developer productivity with this, build rapid yet sustainable paths to production that are tailored to your organization, and of course, coordinate the work of dev and ops and not just say that we're DevOps engineers. We can actually maybe make that a reality and really break down these silos. So one of the greatest things of Backstage is that it's part of TAP GUI. Yay. TAP overall, Tanzu Application Platform, is not a proprietary piece of technology of VMware that came out of the clear blue sky. We're using FluxCD, one of the 2 industry standards for GitOps. We're using Backstage, an amazing internal developer portal technology open sourced by Spotify and part of the CNCF. We're using Cartographer. We're using Pinniped. We're using hundreds of different tools, all part of the wider ecosystem, and bringing it together. Carvel, the latest addition to the CNCF about a month ago from VMware, an amazing tool for the Kubernetes ecosystem. Tekton, BuildPacks, Gripe, Cosine, Tilt, and this is just a few of them.
Exactly.
And the real power here is that all of this is brought together. The CNCF landscape, for those that have seen it, I'm sorry, it's way too big. This is how we can put it all together. VMware have given us these tools, but we could replace them. That's what's nice.
All right, so let's have a quick look at how it looks from the starting point when you want to start a new development. Scott, maybe you run us through the initial bootstrapping experience of an application in TAP.
Yeah.
TAP.
So really the idea is, we want to, again, get that same kind of start.spring.io experience. And this is the Backstage UI. And if we go here to the Create tab, what we get is this thing called Application Accelerator. An Application Accelerator is a catalog with out-of-the-box accelerators we do get from VMware with the platform, but you can also build your own. And these are based off of GitHub repositories with a simple file telling it how to transform the source code for us, automatically generate a repository with different changes based off of inputs that you give it, the developers, and actually auto-generate a Git repository with that source code so you can start working. So if we go here to the to-do service, just as an example, and I click choose, one of the things we can get here is a developer shouldn't need to care about everything. What do you really care about? You care about the name of the application. Do you want to have API documentation exposed in the platform? Yay, awesome. Do you want to include technical documentation so we can actually have documents as code side by side with our code within GitHub and then auto-rendered into the UI for us? No need for SharePoint or fun systems like that anymore. And what type of database do you use? Maybe right now I want to use H2, maybe I do want to use in-memory, or I could just come here and say, hey, I want to use Postgres, and what's the name of that database that I want to use? So let's just type here, I don't know, Spring1 TLV, just because I want to. And we're going to include API docs and include technical documentation. Now, one of the cool things is when I click Explore Files here, this is actually going to go and run a whole level of abstractions on the back end and a lot of transformations. And if I go here, just an example, into DB, and I open up here my to-dos DB, we can actually see that this transformed the YAML and put the new name of the database into the files. This is just a simple example, but we have abilities to do rewrite recipes, to actually change different paths within Java. We can actually change a lot of things to adapt this to us and really make it really easy to start with a new application.
It's basically start.spring.io, but for your organization, right? And you, as the architect in the organization or whatever it may be, he will decide what is the best practices for your use case and your requirements. And it's just not just for Spring. It could be .NET, it can be Node.js, it can be Python, it can be anything you can think of.
Exactly. And one of the great things is, while it does exist in the UI here, you can also get to it. Do you have it here?
Accelerator.
Yeah. Tanzu App Accelerator. It's also a VS Code plugin. So one of the great things about Tanzu Application Platform, we want to meet you where you want to live. Yep. That may be in a developer portal, but very likely it's in the IDE. This, we have IDE integrations with VS Code, with IntelliJ, and the idea is you get the same experience. You never need to leave your IDE. You generate from here what you want. You click generate, and it will open up a new workspace automatically for you on that source code to get started.
All right. So obviously, for the sake of time, we're not going to do it from zero. We're going to start with something already running. So what the platform gives us beyond this initial boilerplate is also it gives us a single YAML file that we call the developer YAML file. Okay, this is the only YAML file that we, as a platform, expect you, the developers, to really have to know or actually care about. And this is a CRD. It's a custom resource definition, like everything else in Tanzu. It's called a workload. It has a name. And you can provide all kinds of parameters to basically customize your application. Now, as you can imagine, most of these customizations were created because Scott clicked on these little checkboxes in the GUI. He didn't have to really create this YAML file himself. So for example, he wanted to register the OpenAPI endpoint with the TAP ecosystem, which we'll see later on. I decided to override the base operating system version with the build pack portfolio. And for example, I created the connection to my Postgres, right? So I have a database, a Postgres database that I created a claim for. So as you can see, all I have here really is just a to-dos DB claim, just like a persistent volume claims for those of you who are familiar with the Kubernetes ecosystem. And I don't have actual URLs or usernames or passwords. None of that is in my code. It should never be there because as I move between environments, I want the binding to be different. So if I'm in a developer environment, I might want to bind to a local container. If I'm in production, I might even want to connect to Amazon RDS. I don't know what's behind the scenes. All I really know is that I have this claim to connect to my database, which is exactly what I want. Now, the code itself, right now, if I go here and I open the application itself, I already have the front end deployed as a Node.js application because TAP can do everything. But as you can see, I don't have any Spring backend running behind the scenes, so nothing can actually be loaded here. So let's deploy our application. What do we need to do to deploy a production-ready Spring application? You've been to my session before, right? 30 minutes of a lecture or reading a 60-minute article to just get the starting point. Or alternatively, I can do here, right-click, and go with live update start. Okay, so what it's doing, it's basically taking the source code on my machine, uploads it to the remote registry where I'm connected, and then it tells the platform, hey, platform, go to this registry, take the source code from that endpoint, and build a production-ready image using cloud-native build packs, which we mentioned throughout the day. Once you've finished building that image, don't stop there. Also, go ahead and deploy it. How do you deploy applications in TAP? There are multiple options, but the default one is using Knative. So you get that serverless auto-scaling from 0 to whatever requirements you may have in your environment. So what we're seeing here is the application is about to start up. We're basically running this command called Tanzu app workload apply, and we are providing this workload YAML that we just provided to the application. Hopefully the internet here is better. Yeah, it works. So as you can see, the build packs are now kicking in, and they are creating my application to work as expected. It detected the correct build packs. It created the image. It's building it. In a matter of seconds, it's also going to sign it and put it in the registry that I'm connected to. In my case, it's a Harbor registry, but it can be anything you might deploy, an Artifactory or a public cloud provider, whatever it may be. And once we're done with building our application and pushing it to the registry, the next step is basically to deploy it. I'm currently connected to what we call an iterate cluster, which is kind of like a sandbox environment where each developer gets his own namespace where he can deploy whatever he needs. I already have the front end deploy there. And right now, the application finished building, and the deployment of Knative is about to be kicked off. So while that is running, maybe we can have a quick look at what we're seeing here in the TAP GUI again. So we saw the different accelerators that we have that we can create various projects from. As Scott mentioned, we also have the ability inside the GUI itself to connect to technical documentation. So here, for example, here's my to-do service application that we're just deploying. I can have access to the source code, and I can even go ahead and view the technical documentation, or basically the README, connected to this particular application. So it can be whatever you write, just simple markdown, available as kind of a wiki, internal wiki in your developer portal, so you can really have a good integration between the different development teams.
And one of the really great things about that documentation as well is that it's globally searchable through the UI itself, through TAP GUI.
Yep.
So as a development team, if all of the organization is using this platform and have the documentation within here, you can globally search for something. You don't remember exactly which service had something or where you found some example in documentation. It's all searchable, it's all very easy, and because it exists in the same Git repository as our code, as we're updating our code, our documentation updates in the UI, and we can have full lifecycle parity between our documentation and the code itself without having the differences, and always to remember to update with the wonderful SharePoint systems or the similar.
Exactly. So our application is up, it's been deployed. I can even see it from the command line if I'd like, and for some reason the resolution here is terrible, but let's do it again. So let's see what I get from the command line here. So I get all the information about how the deployment happened. We basically have the source image. This is the flow that took place in order to deploy my application. And my application is currently running, and I have an endpoint, which I can open right here. And I have my to-dos endpoint API available and running. And if I go back to my front end, hopefully, when I refresh it now, I should have an actual application up and running, and I can go ahead and start producing some messages. Spring 1.2 rocks, but only in Tel Aviv. No. Right? So things work. I have a front end, I have a back end. The back end is already connected to Postgres. I didn't have to understand exactly how that happened, right? I didn't have anything in my application properties that provided the connection details. This is all done with Spring Cloud bindings automatically for you without having to do anything. Now, here's the killer part, right? So we're here, and we have the source code. Now, let's say I want to change something. So I have this handle before save event that I can inject into my application, or even handle before create if I'd like, right? So if I go here, it actually should have been like this. So if I go here and I'm saving my application, let me resize this a bit. The font size is quite terrible, I apologize. Let's go ahead. And where is my console? Mr. VS Code, can you show me my console here? Where is it?
It can, but you're on a Mac. It's an issue.
Split terminal, short terminal. Okay, who can tell me where the terminal? Where?
Just open a new terminal and it'll be another
New terminal.
tab.
All right, you're right. So this is the window I wanted to show, right? All right, so I have my application. Now, this is quite interesting. Look what happens here when I'm adding basically code to my application, right? If I uncomment this portion here, it's basically doing handle before create, and it changes the title of the to-do list that I'm going to do. So if I'm saving this, as you can see here at the log file, it detected the change, it synced the classes from my local machine to the remote Kubernetes cluster, and it restarted the application for me automatically, right? So if I do here and I create some more items, once the application is going back up, it takes about 10 seconds because it's a fairly large application. What I'm going to have here is basically, it's going to create these entries with this new S1T in the beginning of each one of them. So I get basically live update without having to do any special things in my IDE. I just change my code, I save it, it syncs to the remote Kubernetes cluster, and you can do this iterative development as long as you basically like, right? So before we continue to the next part, I'm actually going to show you another thing that we can do here, which is quite useful. And that is, if I'd like to debug my application, if I have any issues, so I can also do remote debugging. So I just ran a remote debug start. And this is, again, going to take a few seconds to redeploy with the debug port enabled. While that's doing that, Scott, maybe we can check the UI and see how we're doing in the runtime resources and things like that, and the live view in the tab GUI.
Yeah, so really one of the great things here is that everything is exposed through the UI, right? So if I come here, what we can see is actually the software catalog, which is all the software that exists within my organization right now. So if we look here and look for the to-do service, and we can come here to the service here, and what we'll actually see, as we saw before, we have the tech docs and the source code, but we also have runtime resources. And what this is doing is this is pulling from all of the different clusters inside of my environment. So this could be in my iterate cluster. This could be in other clusters as well. We have multiple clusters. You can see here we have things in a build cluster, right? So we have multiple clusters connected to the same UI. So this could be dev, QA, prod, everything through a single pane of glass. And one of the great things that we can do is we actually see all of the containers that took part in this build. But if I want to go and actually take a look at my running application, what we'll do is we'll go into the specific pod right here. And one of the great things is we can see pod logs, for example. We get the auto streaming of our pod logs in the UI directly. But what we can also do is get our actuator data exposed through the UI in a really simple and nice manner. Anyone tried to ever get a heap dump out of a pod running inside of Kubernetes? Anyone? I feel bad for you if you have. It's not a great experience. But if I come here, I can auto-generate a heap dump directly to my machine, start working from there. You can change log levels live in your application right on the cluster, whether it's at the entire level or at the entire application level or at specific scopes. Anywhere here, we can go automatically through the power of actuators. We can change this. We can get all of our metrics all visualized through us through nice graphs, through great UIs, directly through a single portal where we get our documentation, our API docs with the full Swagger API documentation and portal. We can change our logs. We can get all of this details in one single place. Again, not making you hop between 30 different tabs. Have one system that you can always trust and always go to as being the source of truth for your organization. And the biggest question is, okay, if we're using this as our supply chain, it's doing everything, how do I get visibility? And that's where we have the supply chain choreographer visibility. And I could go into any of these different applications. Let's go to To-Do UI just as an example here. And we can see all of the different steps that it went through as things are going through, what outputs are coming from one to another. This is an event-driven architecture where we're edge triggering things. So from the source provider, if a new Git repository, if there's a new commit recognized, we're automatically going to trigger the image provider. We're automatically going to trigger then the next one. And it's a really great thing, and we can get all of our logs, all of our visibility also through this same portal.
And it's all Kubernetes native, so everything here basically runs in a Kubernetes cluster. All right, while we were talking, we got the debugger up and running. And if we're going here and we're going to, again, refresh my application, the first thing that we should see when I create a new entry here is hopefully, if the demo gods are with us, we're going to get a breakpoint, right? It's going to work. It's a demo, of course. So what I'm basically doing now, which is kind of wild, is remote debugging against a remote Kubernetes cluster, but I'm working entirely on my local machine. Imagine that in the backend of this Kubernetes cluster, again, I do have Postgres, right? And I do have another container, but imagine it's a real-world application with 10 microservices, and a RabbitMQ, and Redis, and whatever it may be behind the scenes. I can add my own microservice, and again, very similar to the test container talk from earlier, I no longer have to live in this mock-up world. I live in the real environment, which is pretty much the production environment, just a different scale and different implementation of it. So whatever I'm doing here, I can do step over, I can see my debug logs, I can check my variables. Everything works exactly as I expect, right? I can go here and see what to do I'm about to create. Everything works exactly as I would expect in a real local environment that I'm developing it. All right, so this looks great. I think we can go ahead and deploy this application to my software supply chain. What do you think?
Yeah, let's try it, right?
All right. So this is where I'm done as a developer, right? I'm happy now. I'm done. I committed my code to a Git repository. And once I've done that, I move on to my next task, which is always great, right? But my DevOps team or whatever it may be in the organization is going to take my workloads and is going to apply the same workload YAML that you gave me, and I'm going to move it through a software supply chain that contains all of the various guardrails and building blocks that you define in your organization. So if I'm going to do here Tanzu apps workload create, and I'm going to give it that same workload YAML. Notice I'm in a different cluster here. This is my main build cluster, for example, for all of my applications, for all of my teams. And it already exists. OK, let's delete it for the sake of demo. Workload delete. And apply it again. So it asks me to basically approve the YAML file. I'm going to give it yes. And now it tells me, OK, you can monitor the flow here if you'd like. But obviously, as Scott showed you before, it's much nicer to see the flow right here from the visualization. So as you saw, I have all of my different clusters in one location. This is the iterate cluster. This is what I worked so far. This is running source to URL builds. This is like, I don't care about anything else. Give me a working application as soon as possible, right? But now, in my build cluster, the DevOps team or the platform operator decided in this environment, I have to run tests, I have to scan my application, I have to scan my images before I allow it to go on to the next level. So let's see what goes on here. So everything seems to be building. We're currently running tests, and I can go ahead and check if my tests are passing successfully, if I can get this thing to go down. And I have access to all of my tests. Again, this could be with test containers. This could be with any unit test or whatever you define you want to run in this particular environment. And once that's successful, we move on to the next task, which is source scanning, right? So we want to make sure, even if we use things like build packs, that our application is secured, right? And I wonder if this will work. What do you think, Scott?
You know, I hope so.
I hope so too. It's a demo, right? I'm kind of worried.
You wrote the code. If it doesn't work, that's his fault.
It's usually my fault, I admit. While this is running, I want to show you another nice trick here. So in my workload YAML, I said I expose an OpenAPI endpoint under a particular path. And every time I do that, I'm going to get an API portal just readily available for me in the platform, live, on demand, on any redeploy. So if I go here, I see my API endpoint, I see the definition, I see a real-world working endpoint that I can test against, and I can see the entire Swagger endpoint, get all the information, try it out, whatever I may want to do, I have it available for me directly from the same portal. So back to our workload. Let's see what goes on here. Oh my God, we failed. Yeah, that's because I'm the developer, right?
Exactly.
Makes sense. All right, so let's see what we have here. So if I go here, I'm getting a clear message. I failed because I have a violation in my code, right? Why do I have a violation in my code? That's very interesting. So I see all of the information here. I have basically built-in CVE scanning for everything from my operating system up to the Spring application or whatever other application I'm going to use. And it seems like I'm violating some of the policies. So in here, as you can see, we have an entire dashboard specifically to see all of the security threats and analysis in our environment, where we see all of the applications that violate our policy or do not violate our policy. So we have one application, this Tanzu Java web app, that has some CVEs, but it does not violate our policy because the security team agreed to let it continue. But this one appears to have one critical vulnerability, which is just unacceptable. And in this case, what we need to do is basically go ahead and fix our code. Luckily for us, in our case, it's as simple as giving an upgraded version of HSQLDB. So I'm going to go right here, and I'm going to find that dependency in the POM XML, and I'm going to give it a newer version that fixes the CVE patch, and I'm going to commit my code. What do I have to do now, Scott?
Next time, not commit straight to main branch.
Yeah, you're right.
Basically now, you have to do nothing. And that's the fun part. What's going to happen is that automatically, within a minute or two, FluxCD is going to recognize that there's been a new revision. It's going to pick up the new commit to Git. It's going to rerun the tests against this new commit, and then automatically trigger the scanning again. Once the scanning works, it will pass this time, and then it will move on to the next phases. And one of the great things also that we can see here is, sometimes we may want to know what the actual violation is, because in some clusters we may allow certain CVEs, we may not. And this is defined by the platform team. But what we can do is simply click here on the scan policy link, and we can see here which criticalities of CVEs are not allowed, as well as which CVEs specifically we're putting on a whitelist or an allow list. And basically, the great thing here is that this is all configured while we're seeing it here through Rego, a very simple policy language. You could change this completely. This could be custom logic inside, as well as the fact that this is actually only a part of a Kubernetes CRD that's actually wrapping this up. So all of the configuration for how we're running policies, how we're running scans, is also in a declarative format in Kubernetes, meaning it can be managed through Git, it can manage through any type of source control and tools that we use in the standard Kubernetes ecosystem.
Yeah, and one of the really nice aspects of the platform, again, it's modular and it's customizable. So we support out of the box today the Gripe scanner, but also Snyk because it's very popular. And we also support recently Carbon Black container. But you can implement yourself like Scott here is doing in his fun time.
Exactly. If we go here just to this one as an example, this is another tap instance, and I go here to the supply chain visibility. I got bored the other day, and in about 20 minutes, I put together an integration with Trivy. It was fun. Basically about 7 lines of code and wrap it up into a container, and we have Trivy as a scanner. And the great thing is we have the exact same experience here, the exact same user experience, whether we're running Trivy or Gripe or Carbon Black or any other tool that you may want to use, whether it's for source code scanning or image scanning. It's really easy to plug into and add your own opinions, your own tooling.
Exactly. All right, so let's see. It seems our scanning is now successful, which is great. And we have finished building the image. And now we're doing another scan, this time for the actual created build pack image, because the image adds a lot of its own packages, the operating system, the OpenJDK, and they can have vulnerabilities as well. So once we are done with that, hopefully we can now deploy to production. Now, how do you deploy to production? You SSH into the production machine and you run the script, right? No, I hope not. Excellent. What we really want to do is basically do an entirely GitOps approach for all of our deployment to any environment it may be, the testing, the QA, the performance testing environment, and obviously also to production in the end. Luckily, the platform lets us do this very, very easily without us having to do anything in particular. Let's give it another refresh. Maybe it's already completed, and we can continue to the next step. So we are still scanning the image, and once that is done, we can deploy to production. So the scanner is currently running. As you can see, everything, like Scott says, is trigger-based, so everything is basically, it's not like what we would use to from a Jenkins environment or something like that, where it's an orchestrator that goes step by step. Everything is triggered, so the build completed, this triggers the scanner. The scanner completed, this triggers the deployment, etc. Right? And this is exactly how we want these sort of things to happen.
Exactly, and the other really great thing about this is because every step is on its own, if an image were to, let's say, we have build packs and the new base image changes, automatically we don't need to test our code and rescan our source code. We can just, that changed, and we'll just run the part of the supply chain after that. So it's really modular and makes things work much quicker and much faster in your environment.
And this is definitely one of the main benefits here, where you can basically have like 1,000 images with a log4j CVE or whatever it may be, and you apply the build pack or whatever the fix it is, and it's going to apply to all of these images immediately. And you have the visibility from the dashboard to do it as well. All right, so we finished our pipeline, and our pipeline, in my case, is creating a pull request in Git, because that's how I want to deploy to production. And the platform lets me do that fairly easily. So as you can see here, I have an approval mechanism that I can use. So I'm going to use that. So I'm going to look at this approval and check exactly what this change was. So again, I'm using GitHub. It can be any Git compliant solution. It created the pull request for me in a dynamic branch. I know it's OK, but I can check it if I'd like. And then I'm just going to commit this merge. So basically now I moved the deployment into the deploy branch. So I can delete this dynamic branch that I had right here. If you go back here and see what we have here in Git, so this is our sort of a mono repo of all of our deployments. So per microservice or per application, I have its own folder. And for the to-do service that we just deployed, we have 3 YAMLs that are going to be deployed to our production environment. We have the delivery YAML, which is our Knative service being built precisely for our needs, using all of the production-ready recommendations we saw from the talk earlier today. So as you can see, we have the name, we have the various Java tool options with all of the endless parameters that you didn't have to write now, because it was all created by the platform. It has the correct liveness probe and readiness probe in the correct port. Everything is basically working as I expect, right? So if everything should be OK, what we should be able to see now, so in our production cluster, it just pulled the FluxCD again from the GitOps repo, and it deployed it, right? It actually, in the process of deploying it right now, this is actually live. So in a few seconds, we should see a green checkbox here, and our deployment to production is done. Yay, it works. So I think we should do a little trial run. What do you think? Maybe we should ask everyone to check our production environment. So if you want to conclude this wonderful day, if you can all go to go.tanzutime.com. So this is right here. Okay. Hopefully, our production environment is working. Right? You can open your phones. It should work from your phones just fine. So this is our application. And let's start refreshing. What do you say? Are people inside already? Not yet. Who is the first to put a to-do inside? Come on. Yes. Nothing nasty, please. This is being recorded. Hello. Excellent. Go home. I get the message. All right. So again, this is all auto-scaling for me, from 0 to whatever I need, right? So I have this entire end-to-end pipeline, and I think that the message from the to-do was quite informative. What do you think, Scott?
Yeah, I think it really is one of the strengths here, and it's one of the most amazing platforms, that it's the most comprehensive solution from end to end, where we get that great experience at the beginning, that CF push, that Heroku up type of an experience of just start quick, don't care about what's happening, and at the same point, so much more is happening behind that. We can see we're getting testing, we're getting scanning, we're getting API documentation, and it's all customizable through simple Kubernetes YAMLs, but our developers don't need to care. Make the platform team deal with that.
Now, a very important question. Who wants to go to a happy hour? Yay! Guys, thank you so much. Kobe, want to come up on stage with us?